Welcome to the last day of statistics, and it's a review day because tomorrow is the test. Take a minute and read through the warm-up. It's a question on normal distribution, and think about which question or questions you need to use these scores here versus which ones you don't. So go ahead, press pause, read through this, and see if you would know how to answer it. All right, hopefully you had a chance to try it. Let's go over it. It says of the adults in New York State, the average resting body temperature is 98.25 degrees Fahrenheit, with a standard deviation of 0.73 degrees. Resting body temperatures are normally distributed. Okay, so as soon as you see are normally distributed, that's the nice thing about these questions, is it pretty much tells you exactly it's one of these types. It has to say that for you to be able to draw this graph. And now that you know it's normally distributed, you can put the average or the mean in the middle, so 98.25, because that always goes in the middle. What is the probability that a person from New York State chosen at random has a resting body temperature above 99 degrees? I hope none of you do z-scores with a question like this. You go to 99, and you want above 99. So what you would do is you would plot where 99 is, shade the graph above, and then you would just immediately do normal CDF. The lower value is 99. The upper value, it goes up forever, so this is infinity. So you write 1 times 10 to the 99th. The mean is 98.25. And the standard deviation is 0.73. So the calculator figures out the z-scores for you behind the scenes and then figures out what percentage of the area under this graph is above where 99 would be. So I only have an old calculator today, so when I go to second distribution to get that normal CDF, it doesn't say lower, upper, blah, blah, blah. I have to type it in as 99, comma, 1 times 10 to the 99th, comma, 98.25, comma, 0.73. And it'll tell me that it's 0.15211. So the probability to the nearest hundredth would be about 0.15. So about 15% of the people have resting body temperatures above 99 on average. Part B says that what percentile, the nearest tenth, is a person with a resting body temperature of 97.9. So a percentile question, if you see this show up on a test, still got the 98.25 in the center here. Sorry, penguin. 97.9 is over here. Percentile, what phrase were you supposed to think of when you heard percentile? Remember, that means at or below. So I want the percent at or below 97.9, which would be over here. So that would be normal CDF. If you look at your picture, the lowest thing shaded would be negative infinity. So negative 1 times 10 to the 99th. The upper thing shaded is 97.9 with a mean of 98.25 and a standard deviation of 0.73. Okay, then we go calculator. Second vars, normal CDF. Negative 1 times 10 to the 99th, comma 97.9, with a mean of 98.25 and a standard deviation of 0.73. 0.3158. going to set a percentile to the nearest tenth, so you turn it into a percent. 31.58 becomes 31.6. So it's the 31.6 percentile. Okay, so both of these types of questions know z-scores because the calculator does that for you. C is where you would need z-scores. Suppose New York State women have an average resting body temperature of 98.7 degrees with a standard deviation of 0.55. New York State men have an average resting body temperature of 97.8 degrees with a standard deviation of 0.61. If Maggie Brooks has a resting body temperature of 99 degrees and Andrew Cuomo has a resting body temperature of 98.2, whose body temperature is actually warmer relative to their gender? So this is where you have to use z-scores because you have two kind of subpopulations with different statistics. So compare z-scores. So for Maggie Brooks, z-score is always the observed minus the mean over standard deviation. So Maggie Brooks is a woman. Her observed is 99. But the average of New York State women is 98.7. And the standard deviation is 0.55. Versus Andrew Cuomo, who's a man, his observed is 98.2. The men's average is 97.8 with a standard deviation of 0.61. Okay, so we're going to compare these using z-scores because that kind of normalizes the data. 99 minus 98.7. Hit enter. Divide by 0.55. This is 0.54 repeat. And let's try Andrew Cuomo, 98.2 minus 97.8. Hit enter, divide by 0.61, and that's 0.655. So now they're kind of on the same playing field. You can see how far above the mean they are. Andrew Cuomo's is warmer because it's higher. So if you were thinking of comparing z-scores now, that always has a mean of 0. So Maggie would be here, 0.65. Andrew would be here. So the answer would be Andrew. Good old Andy C. And as your last random fact of the year, the only bird that can swim but not fly is a penguin. Pretty special, those penguins. All right. So again, hopefully this clears up when to use z-scores versus when not to. If you go over to the review sheet, this is tonight's homework. I wanted to read through the big picture, maybe go over a couple questions and give you some hints, and then we can move on to the last what you're not allowed to forget. Okay. So first off, we've got basic statistics. That's when you have a list of data that maybe you want to find how much falls within one standard deviation of the mean or some certain standard deviations. A question like that would be like number 1. And I figure it's worth it to do this one together. During a particular month, a local company surveyed all of its employees to determine their travel times to work in minutes. The data for all 15 employees is shown below. So there's 15 employees. Determine the number of employees whose travel time is within one standard deviation of the mean. Okay, so when they ask you for that, you've got to find the mean and the standard deviation. So you go to Stat, Edit, and you put all of these values into L1. So I've got 25, 55, 40, 65, 29, 45, 59, 35, 25, 37, 52, 30. What else have we got here? 8, 40, and 55. And there should be 15 employees, and I'm on 15, so at least I know that I entered them all in. And then if I want to find how many are within one standard deviation of the mean, I need to know what the mean and the standard deviation are. So I'm going to quit out of this, go to Stat, Calc, one variable stats. We only have stuff in L1, so you shouldn't have a frequency list. The mean is 40, and the standard deviation is 14.9-ish. Okay, so for part A, we know the mean is 40, and the standard deviation is 14 point, I think it was like 908, ... So within one standard deviation, you then need to find the mean plus or minus one standard deviation. So in this case, that's 40 plus or minus 1 times 14.908. And that's where I add or subtract. Okay, so I'm going to take 40 minus that 14.908 number, and I get 25.092. And then I would do the mean 40 plus 14.908, 54.908. Okay, so we need the number of employees whose time is between those. So 25 technically is not between it. I'm thinking of, here's my mean, 40. This is one standard deviation below, is 25.092. This is one standard deviation above, 54.908. And if I was plotting these numbers on here, 25 would be just outside that range. So that doesn't count. Same with 55. 55 is just above the range. So that's not within. But 40 is, 65 is too big, 29 is, 45 is, 59 is too big again, 35 is, we've already talked about 25, that's out, 37 is good, 52 is good, 30 is good, 8's way too small, 40 is good, again 55 is just out, you can't round it. So how many of those? 1, 2, 3, 4, 5, 6, 7, 8. So the answer to part A is 8. And then what percentage to the nearest whole number of employees have a travel time within one standard deviation? You pretty much done all the work. We know there's 8 out of 15. They're just asking it a different way. So 8 out of 15, we want to look at what percentage that is. It's 0.53, ... So to the nearest whole number would be about 53% of the employees have a mean driving time within one standard deviation. Okay, so that's what I mean by basic statistics questions, things using that one variable stats. Okay. Next we have normally distributed versus using z-scores. You use z-scores again like the warm-up to compare similar data with different means and standard deviations, but you just do normal CDF to calculate probabilities or percentages of data. Percentile, again, from the warm-up means at or below. So if you look at number 2, the heights of a population of girls are normally distributed with a mean of 63, a standard deviation of 2. It's asking probabilities. B says if there are 450 girls, how many of them are less than 60? So you can find the percentage that are less than 60, then multiply by 450 to get how many. Percentile is an at or below question. So number 2 should be no z-scores. Whereas number 3, where Shannon and Bob are taking final exams, English versus chemistry with different means and standard deviations, this would be where you use these scores. To compare who did better relative to their exam. All right, so after we did all those, we talked about types of statistical studies. There's observational studies where there's no treatment versus experiments where you have treatments. And remember, when you're designing statistical studies, must be randomly assigned. Whether it's an observational study or an experiment, you need to talk about, no, that's not good, randomly assigned, I guess I wanted to say. You must, if you're designing a statistical study, you need to say that participants are randomly assigned. Say that somewhere in there. Okay, once we got past that, we started doing these whole sampling distributions, and those are the dot plots. Again, you don't need to memorize any of these formulas. If you ever do need them, they'll be given to you in the problem. But you have a sample distribution of sample means if you have lots of samples with averages. So the mean of the sampling distribution should always equal the mean of the true population. Anytime you're using margin of error, that's plus or minus 2 standard deviations of the sampling distribution. And that's true whether it's sample means, like the average SAT score, or sample proportions, like the percent of Skittles that are green. Again, with both of them, the mean of the distribution should equal the mean of the true population. Standard deviation of the distribution, if you need to calculate it, the formulas will be given, so don't memorize those. And if they want margin of error, again, when you see 95%, plus or minus 2 standard deviations of the sampling distribution. And the last thing we talked about was statistically significant. It's statistically significant if the observed difference of values, this is like between the two groups, is extreme. So if it's way out at the ends, far from zeros, not typical of chance behavior. Another way to look at if something's statistically significant is if it's outside the range of plausible values. All right, we've been doing questions like this over and over, so I don't think you really need practice with this. As I was looking at the review sheet, the only other question that I thought might be worth going over is part A of number 6, because it's been a while since you've done this. Wegmans claims that 20% of gummy bears in their bulk section are red. Part A was that simulate. Simulate randomly selecting 20 gummy bears using your graphing calculator. What is your sample proportion of red gummy bears? You must show all work and explain your steps for credit to be given. Now this is where you should all have different answers. So I'm going to be checking, and if you just have the answer that's on my answer key, I know you're going to copy because you're not going to have the same random numbers. But this is where you do random integers. So you're selecting 20 gummy bears, and you need the proportion to be red. You can choose what numbers you want to pick. If you pick random numbers from 1 to 100, what numbers should mean red? Well, we need 20% of them to be red. So if you do 1 to 100, 1 through 20 would be red, and 21 to 100 would be not red. But you don't have to do 1 to 100. What else could you do? If you did 1 through 5, what would mean red? Sorry, let's do 1 through 10. That's easier. If I did 1 through 10, what would be red? 1 to 2. 20% of the numbers are red. 3 through 10 would be not red. I almost said 1 through 5 a second ago. You could have done that. If it's 1 through 5, what percentage would be red? We need 20% to be red. What numbers would mean red? Just 1. 1 is red. 2 through 5, not red. So you pick what range of random numbers you want to use. You just need to know that 20% of them mean red. Okay, so when you simulate selecting 20 gummy bears, this is where you go to your calculator and you go to math, You go to math, over to probability, randint. Whatever you want to use. I'm going to do 1 to 100. So if I do 1, comma 100, lower, upper, and then you need to specify how many. How many numbers are we picking here? 20. Selecting 20 gummy bears. Remember, I said you could store it in L1. So if I do store second 1 and hit enter, now these 20 random numbers are in L1. And if I go to stat edit, I can list out all these numbers. So I'm not going to do all of them, but I'll list out a few. 95, 91, 15, 52. Again, your numbers are probably different. But when you do this question, you'll have 20 random numbers, and you want to know what proportion are red. So if I'm doing 1 to 100, you need to say this so that I know what you're looking at. 1 through 20 are red. So for my pictures here so far, that's the only red one. And at the end, what is your sample proportion of red gummy bears? You're going to have a p-hat value, and it's the number of values that were within your red range over 20. So I'd have to count out how many numbers are 1 through 20 out of 20, and my answer should be around 0.2. Okay, so that's how you do that. I think you know how to do part B because it has to do with simulations. And then other than that, I think you should be good on the rest of the questions because it's ones we've gone over a lot. Okay, so your homework is to do this review sheet. So the last thing I want to do in the video is fill out your last what you're not allowed to forget sheet. All right, so if you have the what you're not allowed to forget sheet, I'm going to go over to the back and fill out the last unit. Unit 15, statistics. So stuff you want to know for this test tomorrow. First off, any question that says normally distributed. You go to second vars, which is distributions, and use normal CDF. And again, you don't need z-scores. You can do them, it's just more work. And most people wouldn't use them, so no z-scores needed. But you're looking for the words normally distributed. When you're talking about statistical studies, an observational study, how do you know something's an observational study versus an experiment? Okay, an observational study has no treatment. So all you can do is observe something that's happening. You can't actually have a certain group get some treatment and another group not get a treatment. Margin of error. If they ask for the margin of error, you do mean. Sorry, you just do plus or minus 2 standard deviations. But when it asks for range of plausible values, or if it says something about 95% confident, you do the mean plus or minus 2 standard deviations, which is the same as saying the mean plus or minus the margin of error. Okay, those are the topics that are most heavily tested on the regions. So you should expect those to all come up on the test tomorrow as well. But make sure you know how to do all of those things. All right, if you got any questions, feel free to shoot me an email, but do that review sheets and be ready for your test tomorrow. Talk to you later.